Alright, so motion and calculus day 2. We looked yesterday at a problem that had an equation, and we looked at one that had a table. Now we're going to look at a graph. And these are typically no calculator problems. You see this one's, they don't give us the go on the calculator. And so what I like to do when I'm looking at this problem is first of all know whether the graph is representing position, velocity, or acceleration. Which one?
Velocity.
Velocity. They tell you that. Alright, velocity, and we have units, feet per second. Okay, we need to, if we're going to use units later, we got to make sure we use the correct units. So one thing to do is you could actually start off saying, okay, well let me get a mental picture of what's going on here, and then that may make answering the questions a little bit easier. So initially, when time equals 0, this particle is moving 3 feet per second. That's its speed. And what happens in the first few seconds?
Speed increases.
Speed increases. Okay, so it's accelerating. And then at t equals 3, this is kind of strange. It's not like the speed increases and then decreases and there's, kind of a smoothness to it. There is a sharp turn right here. We do not have differentiability right there, and that may come up later. All right, what's happening from t equals 3 to t equals 5?
So it's going fast, but he's slowing down.
So the particle is slowing down. Which direction is it moving? Same direction still. Okay. Velocity is above the x-axis, is positive, still moving to the right. And then right here at t equals 5, the particle stops because it changes direction, and then it speeds up. So notice that the particle is speeding up here. And we know that because the velocity and the acceleration is negative. We have a negative y value and a negative slope. Speeding up, just in the opposite direction, levels off to some speed. Okay, so this is going to be fun because we're going to be switching back and forth between slides. So on choice A, it says that t equals 4, is the particle moving to the right or to the left? To the right. How do you know? Yeah, velocity is positive. And so that's what we write. Right? And you can say v of t is positive at t equals 4, or you could just say because v of 4 is positive. You can list out what v of 4 is, but you need to write that it's positive. Okay, over what time interval, so we're not just going to have a value, we're going to have an actual interval, is the particle moving to the left?
5 to 9.
5 to 9. Because why?
V of t is negative.
V of t is negative. Don't forget, when you see this explain your answer, you got to write a because statement. All right, so those were, that could get you 3 to 4 points right here already. Remember what I said? If you could consistently get 4 or 5 points, you're not in bad shape. That's pretty good. All right, C says at t equals 4 seconds, is the acceleration of the particle positive or negative?
Negative.
All right, now remember acceleration is v prime. So what are we going to look at on the picture?
Slope.
The slope. So at t equals 4, is the slope positive or negative?
Negative.
Negative. Can we say because?
So V of t is
I don't know why I wrote plus there. That really should have been prime.
Yeah.
So v prime of 4, and I'm going to go ahead and write, which is the slope of v of t at t equals 4. It's maybe a little bit more than I need, but it answers the question. It has everything I need. Yeah.
So I have a question for it. 3 is kind of like theoretical, but at the cusp, quote unquote, if you zoomed in on that, in reality, wouldn't that be a curve?
In reality, it probably should be a curve, but when you're talking about a particle, you can't think of it as like a car. It's got to be, you got to go on what the graph says, and so no, you can't assume that, and that's going to be important here in the next couple of parts. All right, average acceleration. What does that make you think of? Era. All right, so they give us our 2 endpoints, so you have to show this step. V of 4 minus V of 2 over 4 minus 2. You can't just look at it on the graph. You got to show that. I think a lot of you could find the slope, but you need to show this. So v of 4, what is that? 6. V of 2, 9. So this ends up being negative 3 over 2. It does say indicate units of measure, and that's going to be feet per what? Second? Second squared. How do you know it's second squared? Acceleration. Plus, thinking about this fraction here, feet per second is feet per second squared. If this part was 2 points, and they give you 1 point for showing this and 1 point for the answer, well, I got 2 points. If you left off the squared here, you could possibly miss your whole point. They don't do half points. So, like, if there's 1 point allotted to the answer with correct units, it doesn't even matter if you get the answer right if your units aren't right. So you've got to be really careful with units. It's a big, big deal. All right, so this next part is easy. I mean, easy? I didn't mean to say that. It isn't easy, but it's interesting because it says, is there guaranteed to be a time such that v prime, what is v, if part D found a rock, what is v prime suggesting? I rock. So they're basically saying, is the average rate of change, so for sure, going to equal the instantaneous rate of change? Okay, this actually normally is true. This, Brett, has to do with what you were saying. It normally is true because normally, or a lot of the time, my graph is very smooth and every single tangent slope that's possible is included. And it's differentiable. This has to do with mean value theorem. The two things that had to be true for mean value theorem were continuous and differentiable. All right? Now, if you didn't think about mean value theorem, you could just look at the graph and say, is the slope ever negative 3/2? Look, here's the slope. What is the slope right here?
Not negative 3/2.
Not negative 3/2. It's negative 6. Is the slope ever negative 3/2?
No.
Specifically between 2 and 4, I think is when they want you to. No, and this is because this is a cusp. If this had been rounded out, you would on this one say yes, and you could quote mean value theorem, or you could write out what it means. But no, it's not guaranteed. So we could say there's different ways you could explain this. But basically, if you put something in here like, you don't have to list out, you can't use the mean value theorem. But you could say v prime of 3 is undefined. So I'm going to write, so no mean value theorem. That's the easiest way to explain it. You could list out, though, the instantaneous rate of change does not have to equal the average rate of change because it's not differentiable. Let's go ahead and move on to part F. So here, I want you to cross out, explain your answer. That really wouldn't be here on part F. Okay, it says, at what time t in the given interval is the particle farthest to the right?
5.
What does everybody else think? He's right. 3. If you really understand what was going on here, it's more obvious. Moving to the right, faster, 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 slowing down, but still moving to the right. And then right here at 5, we start moving to the left. So when is it furthest to the right? Yeah. At 5, the particle has stopped, so you can say it is happening at t equals 5. This is kind of hard to explain. That's what I'm saying. I've never really seen that on one of these. This is just retyped, and I think we just put explain your answer on every single one. Yeah.
At 6, is that also cusp?
It's a cusp. Yes, this is a cusp, so that could be an issue. And you're right in saying that normally the graph would look like this.
Yeah.
In reality, if we were just physically like a car, this would have to happen.
Yeah.
All right, but we go with what's said. Okay. One quick thing I do want to talk about is yesterday we kind of ended this right here. And this should be 28, okay? It does work in your calculator. I know in mine we were kind of like rushing right at the end. I do want to list one more, I want to explain one more thing about how you would do this without a calculator. Okay? I doubt it's going to be on your AP test, but it might. And so I just want you to have all opportunities to do well. Without a calculator, what you would have to do is graph V of t. Now, because you already know, they actually help you out here. You know V of 0 is 9, and you know that 1 and 3 are your roots. You actually already know the graph of what this looks like. Okay, it's a parabola, and it looks like this. So without a calculator, what you would have to do is integrate right there from 0 to 1. Okay, V of t. And you'd have to do that by hand. All right, but it wouldn't be that hard in this problem. And then I put plus there, but I shouldn't. Because look at this next piece. If I just integrated from 1 to 3, my answer would be negative. But with total distance, I don't want it to be negative, so you'd have to put a minus there. And then you'd add the integral from 3 to 5. So you'd have to do 3 different integrals. It would be a lot of work. I don't think it's going to be on there without a calculator, but you can do it. All right? I really don't want to spend any more time in class on that. So do you know speed? So I'm going to go over the first 3, and then I'm going to give you a minute to kind of look at the next ones. So speed is the absolute value of what? Velocity. Okay, we know that. If the velocity and an acceleration have the same sign, this would be both positive or both negative. Okay, then speed is increasing. That makes sense. It makes sense for at least both positive. Both negative would be like on that last graph when the slope was going down and you were below the x-axis. So what do you think would be good to go in the blank for number 17? Speed is decreasing when different, opposite. So this would be where one is negative and the other is positive, or vice versa. Okay? Alright, so what I want you to do is to read through, and this is really more of a test of logic than anything else. All of these, fill in the blank, your answers are going to be like increasing, decreasing, positive, or negative. It's one of those 4 things. Go ahead and see how many you can do on your own. Understand one, skip it, and go on to the next one. Alright, let's go over these. I know a lot of you are not done. That's okay, but you've at least thought through some of them. So if velocity is negative and acceleration is positive, and one thing you might want to do on these if you're confused is actually write that out. Then speed is doing what?
Decreasing.
It's decreasing. DEC is appropriate abbreviation for decreasing on the AP test. They accept that. Alright, if velocity is positive and speed is decreasing, now when they give you speed is decreasing, that tells us that we have opposite signs. Then what should acceleration be?
Negative.
And NEG is appropriate for negative, appropriate abbreviation. Velocity positive, decreasing speed, again, opposite signs. Oh, sorry. I'm going too fast. Let me back up. Speed is, velocity is positive and velocity is decreasing. If velocity is decreasing, what's happening with acceleration? if velocity is if a function is decreasing, then its derivative is negative. That's what that tells you right there. So we have opposite signs, so speed must be decreasing. What I'm trying to do here is, some of you are really good. This is intuitive to you. You got it. When you get to one that's not intuitive, think it just go through the logic part of it. All right. So here, speed is increasing. That means we're going to have the same sign. Acceleration is negative. So what must velocity be? Negative, because they have the same sign. I'm not even like imagining what velocity and speed. I'm just using the rule. Okay, if velocity is negative, and here velocity is also increasing. So what does that tell me about acceleration?
Positive.
Positive. So these are opposite signs, so speed must be decreasing. It's really easy to get turned around on this. And some of you look confused right now. I'm not even in my mind imagining velocity and acceleration. All I'm doing is listing out what they tell me and using the fact that opposite signs means speed's decreasing. Same signs means speed's increasing. I'm just using that rule. All right, so what about 23? Who got it? What do you got?
Negative.
Negative? Positive? Let's break it down. If the particle is moving to the left, that tells us that velocity is negative, right? Speed is decreasing. When they talk about speed, it's opposite signs or same signs. Decreasing would be opposite signs. So acceleration must be positive. And you can use the signs, negative and positive, like that as well. All right, let's talk about the 3 scenarios of when to integrate velocity. Okay, so because it's easy to get these 3 mixed up. So notice on 24, there's no bounds. What we call this is an indefinite integral. It means that when you integrate, you get an expression. You have a polynomial, you integrate, you get another expression. What is this an expression for? Position. At time t. This is, don't forget that you will have a, when you integrate and there's no bounds, what do you have to write at the end? You have to write plus c. Okay, I want you to write these words, initial value. Okay, they're going to give you some kind of initial value that's going to help you find your c, which we haven't practiced yet. I'm going to try to squeeze it in at the end of this lesson. All right, well, when you have bounds, all right, this is called a definite article. I was saying that earlier, integral, definite integral. So the answer will be not an expression. What will your answer be? A number. You're going to plug in values for x and for x, the upper bound, lower bound. The number represents the change in position. So what this means, if I were to integrate from 1 to 2 for some velocity expression, I will get how far is this particle away, like at 2, how far is it away from where it was at 1? That's what you're getting. So it could be from where you started, or it could be from where the integral starts. This is also called displacement, okay, over the time interval. By the fundamental theorem of calculus, this tells us that really all we're doing is subtracting the 2 positions. You know position at 1, you know position at 2. You don't have to go through this whole mess. You just subtract the 2 positions, and you get your new. You get the how far it was. So it says this is also known as displacement. The answer can be positive or negative, just like your position can be positive or negative, depending on whether the particle lands to the right or to the left of the original starting position. All right, what happens when I put absolute value bars around velocity? By the way, this is also a definite integral because it has numbers.
The total distance.
It represents the total distance. So here's the difference between 25 and 26. 25, if I'm in my car at my house and I drive to work, okay, it shows me how far from my house to my work, okay? 26 is going to take into account, did I run errands on the way to work? Did I go drop somebody off? Did I go pick, like I went out to eat lunch today, you know? And total distance has to do with all of that driving, all right? So it's still represented by a number, but that number should always be positive. And the absolute value bars kind of tip you off on that. All right, 27 says let's revisit. We actually already did this. I showed you both ways to do that. All right, I want you to turn to the next one. I'm going to see how much I can get this squeezed in. Turn to 2. All right, so your homework, by the way, is just to finish this packet. All right, due Thursday. Particle moves along the x-axis so that its velocity is given here. Then they give us an initial position. What they're saying is x of 2 equals 5. Okay? Let me rewrite that so you can actually read it. So it says write the polynomial expression for the position at any time. So what would we do to velocity to get position? We just talked about this. We would integrate. Okay? So we are going to integrate an indefinite 3t squared minus 2t, and you could use your calculator here, but it's really easy to do without. All right, it would be t cubed minus t squared minus t plus c. All right, we need to solve for c. Immediately, we need to solve for c. Okay, we're going to use this piece of information right here. Okay, so we're going to plug in 2 in for t. 2 cubed minus 2 squared minus 2 plus c equals 5. Okay, that would be 8 minus 4 minus 2 plus c equals 5. So 8 minus 4 is 4, 4 minus 2 is 2. Subtract the 2 and we get 3. Does that sound good? I did that really fast. So you plug in this number in for t, you plug this number is equal to 5, like the x value. So my expression, really, I need to erase this plus c. I would probably rewrite it if I had more room, but I'm going to write plus 3. This right here gets you the full credit there, and it's going to make sure that if you use this equation. Okay, so anytime you're integrating, in general, you've got to find that plus c, and they're going to give you some information to do it. You have to do that on a couple other problems, and we hadn't practiced it yet. Are there any questions on that? I know I went through it really fast. Okay.